In this video, we're going to look at the basics of probability. The probability of an event happening is the chance that it will occur. We always measure probability between 0 and 1. So we can consider an event, every event, having a probability somewhere between 0 and 1. So we can think about probabilities as decimals, like 0.25, 0.75, or as fractions, or as, obviously, percentages. So you might say there's a 25% chance of rainfall one day, or you might say that there's a 3 out of 4 chance that you might do well on a test if you've revised. There are different ways of thinking about probability like that. One way that we don't generally use probability at GCSE is ratios. You might see that in horse racing. We don't tend to use that for probability. Here's a quick question for you to have a go at. See if you can place these events on the appropriate parts of the probability scale. Here's a question for you to try. See if you can place the events on the appropriate parts of the probability scale below. Please pause the video now and have a go, and when you're ready for the answer, press play. Okay, so we should have, getting superpowers tomorrow sadly is going to be impossible, so that would be 0. We'd say there's a probability of 0 of that happening, or impossible. When I flip a fair coin I get heads. Well, if you think about it, even without knowing anything about probability, we should know that a coin has got two faces, heads or tails, and they're both equally likely to be landed on. So we're going to say even chance for that. C, I will see a pink car while driving on the motorway, quite unlikely. D, one of your friends will have chips for tea one day next week. That's going to be likely, probably not certain, but likely. Something for certain could be that the sun will rise tomorrow, something like that, and then you would describe that as certain with probability 1. In maths, we're obviously more interested with calculations to do with probability. Now, in situations where all the possible outcomes have an equal chance of happening, we use the following formula to work out the probability that that event will happen. Probability is number of ways the event can happen divided by the total number of outcomes. So, for example, I've got a box of counters here. I shake the box and choose a counter at random. So what that means is that every counter has an equally likely chance of being chosen. So we have to imagine now that I've got a blindfold on. I'm not choosing a counter. I'm picking one at random. So what is the probability that I get a blue counter? Well, I need to work out how many ways are there for me to get a blue counter. Well, because there were 2 blue counters being chosen, because there were 2 blue counters in the box, that's just going to be 2 out of how many counters there are in the box, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the chance that I get a blue counter is 2 out of 9. The chance that I get a red counter, whole new situation now, is going to be 4 out of 9 because there are 4 red counters and 9 counters in total. The chance that I get a green counter is 1 out of 9 because there's only 1 green counter. For D, I want to work out the chance of getting a green or a red counter. So I need to count how many ways can I get either a green or a red. Well, even though I'm only choosing 1 counter, there are 4 reds and 1 green. So in fact, there are 5 possible ways I can get a green or a red, which satisfies my event. And there are 9 counters. So there's a 5 out of 9 chance that I get a green or a red counter. And if you notice, that's just 4/9 plus 1/9. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Okay, let's go through the answers. So, Kelly has a bag of marbles. She shakes the bag and takes out a marble at random. 3 are red, 4 are grey, 2 are blue, and 1 is black. The probability of her choosing a red marble is going to be 3 out of how many marbles she has. Now, she has 3, 7, 8, 9, 10 marbles. So there's a 3 out of 10 chance that she chooses a red marble. You could also say 0.3 or 30%. The chance that she chooses a red or a blue marble is going to be 3 plus 2, which is 5, out of 10. We could simplify it, but generally in probability we leave it like that. The chance that she does not choose a red marble, I can work this out by adding up all of the marbles that are not red. So that's the greys, the blues, and the black. So that's 4 plus 2 plus 1, which is 7. So there's 7 possible ways of me not choosing a red out of 10 possibilities. So we say 7 out of 10, or 7 over 10. Which colour of marble is she least likely to take out of the bag? Well, there's only one black marble, and that is the marble which comes up the least. So the colour of marble that she's least likely to take out is black, with a chance of 1 out of 10. Exhaustive probabilities are probabilities that make up a situation in its entirety. We say that exhaustive probabilities add up to 1. So these are probabilities that make up all of the possibilities in a situation. So if we imagine flipping a coin, you can either get heads or tails. The probability we get heads is a half, and the probability we get tails is a half. And as you notice, if you add up half and a half, you get 1, or 100%. So we can say that heads and tails are exhaustive probabilities when you flip a coin. For example, here, Sue has red, blue, and green marbles in a bag. We know the probability of choosing a red marble is 0.4, probability of choosing a blue marble is 0.2. What is the probability she chooses a green marble? Because there are only red, blue, and green marbles in the bag, there you go, if we add up the probabilities we know, 0.4 plus 0.2, we get 0.6. Altogether, the probabilities need to add up to 1. So the missing probability is 1 take away 0.6, which is 0.4. So the chance that she chooses a green marble, which we can write as P bracket green marble, the chance that she picks a green marble is 0.4. Kelly has either toast or cereal for breakfast. The probability that she has toast is 80%. What is the probability she has cereal for breakfast? Well, this example says that she doesn't have muesli or, she either has toast or cereal. She doesn't have another option, doesn't have like a bacon roll or something like that. Those are the only options she has. So the probability that she has cereal needs to add up with the probability she has toast to make 100%. So that needs to be 20%. Finally, Simon either walks, cycles, or takes the bus to school. The probability he walks is 1 out of 6. The probability he cycles is 2 out of 6. What is the probability he takes the bus? Well, if I add up again the probabilities I know, I've got 1 out of 6 plus 2 out of 6, which is 3 out of 6. So, to get to 6 out of 6, which is 1 whole, I need to add another 3 out of 6. So the probability that he takes the bus to school needs to be 3 out of 6, which is a half. So really, he takes the bus to school approximately half the time. Here's a question for you to try. Please pause the video now and have a go, and when you're ready to go through the answers, press play. Here are the answers. So the probability that Sam will have pizza is 0.4, probability he will have pasta is 0.2, and the probability he has fish and chips is identical to the probability he has stew. And we want to work out the probability that he has fish and chips. Well, to do this, if I do 0.4 plus 0.2, and then I want to say plus the probability of fish and chips, plus the probability of stew, that's going to be 1. Now 0.4 plus 0.2 is 0.6. So that means that the probabilities that I don't know will add up to 0.4, because 0.6 plus 0.4 is 1. So I've got 2 unknown probabilities adding up to 0.4, and I also know that they are equal, they're the same. So that means one of the probabilities must be half of 0.4, which is 0.2, and that's the same as the probability that he has fish and chips. Question 2, I throw a 6-sided die. What is the probability of throwing a 5? Well, again, this is equally likely outcomes. As long as it's a fair die, in fact, all of the faces are equally likely to be landed on. There's one 5, there's one face with 5 on it, this one, and that means that it's going to be a 1 out of 6 probability. For 3A, what is the probability of pulling a red piece out of the bag? We should have 6 out of 6, 9, 10, 11, let's count these again, 6, 10, 12, 15, it should be 6 out of 15. Probability of choosing a red or a blue piece, well, there's 6 reds and 3 blues. 6 plus 3 is 9, so 9 out of 15. And lastly, there are 2 green pieces, and there are 15 pieces in total. So that's 9, 13, in fact, which are not green. So there's going to be a 13 out of 15 chance that we do not choose a green piece.